All right, let's try 7.3, computing the values of trig functions of acute angles. So we're going to learn about some specific angles in this chapter, most notably 45 and 30 degree angles. So we'll start with 45, which is otherwise known as pi over 4 if we're talking in radians. So you need to start recognizing pi over 4 as the same thing as 45 degrees because the sine, cosine, and tangent values will be the same. Okay, so what do we know about a 45 degree angle? We know that the A and the B are going to be equal to each other. So we could call both of these 1. All right, since 45 means the height and the width will be the same. To figure out C, 1 squared is 1, 1 squared is 1. Add those together, we get 2. So C is going to be the square root of 2. So this is your 45 degree triangle. You've got 1, 1, and root 2 as your side lengths. All right, knowing that, let's figure out some exact values here. What's the cosine of 45? Looking back at our triangle, cosine is going to be adjacent over hypotenuse, 1 over root 2. What's the cosecant going to be? Remember, cosecant is the flip of sine. So sine would be also 1 over root 2. So root 2 over 1. If we flipped it over, those will cancel, and we end up with 1. What about the tangent of pi over 4? Tangent would be opposite over adjacent, so just 1. And sine is 1 over root 2. So we end up with, since we're timesing, 1 over root 2 or root 2 over 2. All right, try 5 and 17. Okay, so 30 degrees and pi over 6 are the same angles, degrees versus radians. And 60 degrees is the same as pi over 3. So we're going to have some special relationships for these as well. All right, so we know that if 30 and 60, we're going to call our hypotenuse 2. And if we have 2, then we could split this in half and have 2 and double A, which means that A would be 1, right? If we doubled a 30, we'd end up with 60. And so we'd have a 60, 60, 60 triangle, so all these sides would all be the same. So A is 1, and if we plug that into the Pythagorean, B ends up being root 3, right? 4 minus 1 is 3. All right, so 30 is going to be across from the 1. 60 is going to be across from the root 3. So we'll keep that in mind for our sines and cosines. Here is a nice table. I would print this out or pause the video and copy this. This has all 6 values for all 3 of those important angles. So our important angles are 30, 45, and 60, pi over 6, pi over 4, pi over 3, and then the corresponding values for the sine all the way through the cotangent for those angles. Okay, so let's plug some in here. Sine squared of pi over 3. So sine of pi over 3 is the same as sine of 60, which is root 3 over 2. If you don't believe me, go check your table. And we're going to square that, plus the tangent of pi over 4. Tangent of pi over 4 is 1, and 1 squared is still 1. And so what do we have here? Root 3 squared is just going to be 3 over 4 plus 1. We end up with 7/4. Sine of 60, again, is root 3 over 2. Cosine of 45 is root 2 over 2. Just grabbing those from the formulas. You'll start to memorize these fairly quickly. Root 6 over 4. And lastly, cosine of pi over 3, that's a half. The cotangent of pi over 4 is the flip of the tangent of pi over 4, which is 1. A half minus 1 is negative a half. All right, try problems 9 and 19. Okay, so some angles aren't nice and pretty. They aren't the 30, 45, or the 60s. So sometimes we have to use a calculator. So cos of 48 degrees. Let's go grab our calculator. Now, very important here that we're in the right mode. If you hit the mode button, make sure you're in degrees if you're doing a degree problem. So here we are. Let's go back out and figure out what's the cosine of 48 degrees. And you get 0.669. What's the cosecant of 21? Okay, your calculator does not have a cosecant button, but we do have a 1 divided by sine, because cosecant is the flip of sine. So we do 1 over sine of 21. Okay. Conversely, you could do this. You could say, okay, sine of 21, and then flip it over, because your answer is going to be the flip of sine, and you get the same thing here. All right, last problem here is in radians, so we need to go change our mode to radians. And now we're going to do the tangent of pi. Don't use 3.14. Use the pi symbol, the pi button on your calculator, over 12. And we get 0.2679. All right, try problem 29. Nope, there's our values once again. Okay, so now what are we actually going to use this for? Let's use these for some applied problems. All right, so constructing a rain gutter. So we have this flat sheet of metal that's 12 inches long. At the 4-inch mark, we're going to bend it up some degree theta. All right, so by the law of opposite internal sides, this is also theta. Let's figure out what the area of this whole thing is here. All right, so we know this middle area here is going to be 4b, right? Length times width, if this is b here. What we need to do here, so let's see, before we get into that, the area of this triangle is going to be half a times b, and so is this triangle, half a times b, right? Half length times width. So our area is going to be 4b plus a half and a half make a whole, so 4b plus a times b. All right, we need to figure out a and b in terms of theta. So we're going to use this triangle right here. Okay, I think they print one out for you. There we go. All right, so if we want to figure out a, and we know that this length is 4, and we have theta, we're going to use the adjacent and the hypotenuse to do cosine. So the cosine of theta is a over 4. So 4 cosine theta equals a. By the same thinking, sine of theta is b over 4. So 4 sine theta equals b. All right, let's go back to our formula here, 4b plus ab. So this is going to be 4. b is 4 sine theta. Plus ab. A times b, so we'll have 16 cos theta times sine theta. 4 times 4 here is 16 as well. So we both have 16, so we both have sines. Let's pull it out. 16 sine theta. 1 plus cos theta would be our formula. All right, so we can plug in some angles here, but I'm going to skip down to putting it into the graphing calculator here, and let's let the calculator do some work for us here. So let's go into y equals. I've already plugged it in here, 16 sine. Now, if you see here, there's a theta symbol on there, but it's going to make an x on your calculator, right? Times 1, and I've typed the rest of it in there, 1 plus cosine theta. All right, let's go to our table first. Make sure we're in degrees, which I'm not. I'm in radians from the last problem, so we're in degrees. And let's go ahead and solve. Independent needs to be an ask. So if I plug in 30 degrees, I get 14.928, and this would be in inches squared. If I plug in 45, I get 19.31. Let's plug in 60, 20.785, and 75. Oh, it starts to go down again. So I'm guessing we might be better off at 60. Let's go ahead and graph this thing. I'm going to start with a standard zoom, just so I can show you the zooming process. Standard zoom is, oh, sorry, in window. No, zoom standard, where are you? It's probably right in front of me and I missed it. There it is, zoom standard, number 6. All right, here comes our graph going up. Okay, so one big problem that we have is that theta is in degrees. So when we go to our window, our x min, -10, that's fine, but we need to go all the way up to 360 degrees, right? We need to go through a full rotation here. I guess 90 would probably be the smallest that we would need. Let's change that. Because once we rotated this thing straight up and folded it in, we're going to start getting minimal angles in there. All right, so let's start by graphing that. And oh, we have run out on the top. We're not seeing the top, and is it going to come back down? Nope, we're not seeing that either. So let's go ahead and do a zoom fit, which is 0. now we can see the top of it. So let's go find that maximum point. Calculate the max, which is 4. Left bound, right bound, moving the cursor along. And guess. And we were right. 60 degrees is 20.78 would be our maximum point. Let's try another one here. Oh, before we do that, try problem 61. Okay, let's talk about finding the width of this river. So a surveyor can measure the width of a river by setting up a transit. That's that triangular device that on a tripod that you see surveyors in the orange vests working with sometimes on the highways. All right, on one side of the river and taking a sighting of point A on the other side. We walked 100 meters from the transit to point C and figured out there was an angle of 30 degrees. Find the width of the river B. All right, so we're going to think about our trig relationships. From our angle, we have an opposite side and an adjacent side. So we have a tangent function. Tangent of 30 is opposite over adjacent. So we're going to have 100 times tan 30 is the width of your river. Now tan 30 is root 3 over 3. But since that's not going to come out clean, let's go to our calculator and figure out what 100 root 3 all divided by 3 equals. So 57.74 feet. Is it feet? No, meters across your river. Try problem 69. All right, so last thing we're going to get into is the angle of elevation and depression. Angle of elevation is if you look straight out along the horizontal, along the horizon, and look up. What would that angle be? Depression, same thing. We're looking straight out and we look straight down. The angle between the horizon and our angle of sight is the angle of depression. All right, so last problem to try here. Meteorologists find the height of a cloud using an instrument called a ceilometer. Not sure how to pronounce that. We consist of a light projector that travels straight up, so that's here. All right, and we have a base that detects the light, and so our base was 300 feet. Our angle was 75 degrees. We're trying to find the height. So again, this is tangent because it's opposite over adjacent. So tangent of 75 equals h over 300. All right, so at this point, 300 tan 75, and we're definitely going to the calculator for this because 75 is not one of our pretty 30, 45, or 60 degree angles. So 300 times tangent of 75, and so 1,119.62, and this is in 300, where are you? Feet, there we go, 300 feet. So this would be 1,100 and almost 20 feet. All right, try problem 71, and, oh, I apologize. I made it seem like we were done. One last one, 71, and then we're doing this one. Okay, we want to find the height of this statue up here. We know that to the top of the statue is 56.5 degrees, and to the top of the building here is 55.1 degrees. We have a base of 400. So, here's what we're going to do. We can figure out this height, the height all the way to the top of our statue. We're going to figure out this height, the height to the top of the building, and if we subtract them, we'll have this height here. So, tangent of 55.1 equals all the way to the top of the building. So why don't we call that height sub b over 400. And I've already plugged that into the calculator, and if you plug that in correctly, you get 573.39. Let's try tangent of 56.5 equals the height all the way to the top of the statue over 400. I plugged that in as well, and you get 604 feet, 0.33. And so if you subtract those from each other, you end up with 30.95. That's the exact value if you keep all the decimal places in your calculator. All right, now last one, problem 77. And your job here is done. Any questions, we'll go over them in class. Make sure you're understanding the word problems. If not, make sure we're asking those questions in class. Good luck and see you later.